We now correct the third question. And what I'll do is I'll start by copying out the sequence of numbers we have. Those are -3, 4, 11, 18, and 25. And we need to find the formula for the nth term of this sequence. So, as always, what we need to start by doing is look into the differences between the consecutive terms of this sequence, going from left to right. So from -3 to 4, that's +7. From 4 to 11, again, we're adding 7. From 11 to 18, we're adding 7 again. And from 18 to 25, again, we're adding 7. Now, since we're always adding the same amount, that means that this sequence is linear. And because it's a linear sequence, it must have a formula that looks like un equals to a times n plus b. So our job now is to figure out what the values of the coefficients a and b are. And luckily for us, we do that using two equations. Those two equations are a equals to the difference and a plus b equals to the first term of the sequence. So those two equations are the equations that we can use for any linear sequence. And so for this particular sequence, they become a equals to, well, the difference is 7. So that's a equals to 7. And a plus b equals to the first term of the sequence, which in this case is -3. So we go ahead and write a plus b equals to -3. We now have our two equations. So we go ahead and solve them. A equals to 7, well, there's nothing to do there, that's done. The second equation, a plus b equals to -3, becomes 7 plus b equals to -3, since we know that a is 7. Now we have to subtract 7 from each side of this equation, so that leads to b equals to -3 minus 7, and -3 minus 7 is -10, so b is equal to -10. And we now have the values of both coefficients. Finally, we can go ahead and write this sequence's formula, and that would be un equals to 7n minus 10. And there we have it. That's the formula for the nth term of this sequence.